Okay guys, welcome to the stream. Today we're gonna continue the series about XSS. I guess today will be the last day when we are exploring XSS. So like today we'll be checking the common bypasses, like how you can bypass certain things like certain defenses, CSP, mutations, and some other stuff as well. So we're gonna try to finish those by following Beyond XSS articles, and starting from tomorrow we're gonna start exploring other client-side attacks which are not XSS. So finally. All right, so let's get started. I guess let's get started. Let me switch the screen. So we can see we covered like the first chapter, the second, most of the second chapter, like those 4 articles. I haven't actually read all of those through, but mainly those 2 are really interesting. And right now it's ready to check the attacker side, how those defenses could be bypassed. So let's continue. Previously, we discussed how developers can set up the content security policy as the second line of defense for websites, preventing attackers from executing JavaScript even if they manage to inject HTML. This significantly reduces the impact of attacks, since CSP covers a wide range of elements, including scripts, styles, and images. Each website CSP configuration may vary. It is important to set up CSP based on the content of your own website. Yeah, so this is just basically recommendation for developers. And even though if CSP could block scripts, for example, like executing JavaScript, it doesn't mean that there won't be other bugs. We will learn this little bit in the future, but sometimes just including style tags could lead for some interesting vulnerabilities. Alright, however, if CSP is not properly configured, it is almost as if it's not ended up at all. In this post, let me show you the common ways to bypass CSP. Okay, so bypassing via unsafe domains. If your website uses public CDN platforms to load JavaScript, such as unpackg.com, it is possible that CSP rule is set up as script source, like using this website. In previous discussion on CSP, I asked what the problem with this configuration. Now let me reveal the answer. The problem with this approach that it allows loading all libraries from this origin. To address this situation, someone already created a library called CSP bypass and uploaded it. Here is an example. Okay, so this is like content security policy using the meta tag. If you don't know what I'm talking about, you can check not previous but the one before stream where I have shown like common defenses. So you can check this out, but basically it's setting up the header which will say like you can load the scripts only from this page. And actually user, for example, imagine that user could inject those scripts, so he will just inject some custom JavaScript, but that custom JavaScript will be used on that page, and this way you might bypass those limitations, so just by using the same website. All right, I only want to load React, but I'm too lazy to write complete CSP configuration, so I only wrote the HTTPS on package.com, allowing attackers to load the CSP bypass library, specifically designed to bypass CSP. The solution is to avoid this CDN altogether and write complete path in CSP configuration. Instead of just just write like specific path. So yeah, because if you use this, you can basically allow to load any library from there. All right, bypassing via base element. When configuring CSP, it's common practice to use nonce to specify which scripts can be loaded. Even if attacker injects HTML, they cannot execute code without knowing the nonce. Here is the example. All right, so this is the nonce. After opening the console, we can see the error. Refuse to load script example.com my.js because it violates the following content security policy directive. Script source non-abc 123. Note that script source lm was not explicitly set, so the script source is used as fallback. Although it seems secure, but there is one thing forgotten: the base URI directive. The directive does not fall back to the default. The base tag is used to change the reference location for all relative paths. For example, yeah, okay. Because base href equals https example.com is added, the script loading app.js becomes example app.js, allowing attackers to load scripts from their own server. Yeah, this is really crazy bypass. The solution is prevent this bypass to add base URI rule in CSP. For example, use base URI none to block all the base tags. Since most websites do not need to use base, you can confidently add this directive. Yeah, so what is like real takeaway? If you've seen the previous stream, what I recommend doing is using the special tool for just checking special tool for just checking the CSP rules. Okay, let me quickly see one thing. Come on. It looks like this stream is not working on Twitch. That's kind of weird. Let me check. Okay, I am streaming on YouTube at least, so that's kind of good. Let's see. Let me quickly check the chat. All right, that's cool, because it looked kind of weird for me, because on my Twitch manager it haven't showed that it's actually streaming. I don't know what it was. I guess some connection error or something, but right now it's fine. Yeah, hello, thank you for joining. I'm checking some CSP bypasses. This is really interesting topic if you are working for bypassing certain limitations when you're trying to achieve XSS. So this is kind of advanced topic, not for everyone, but still I gonna like do the stream just for like showing you a couple of things. All right. Bypassing via JSON-P. JSON-P is a way to retrieve data from different origins, but I personally consider it as all workaround to emerge from before cars matured. Normally, browsers prevent interaction with non-same origin web pages. For example, executing fetch for example.com. Oh, whoa, what happened? Within the block HULIT1 will result the following error. So access to fetch that from origin this blocked by course policy. No access control. Allow origin header is present on requested resource. Okay, if the opaque response serves your needs, set the request mode to no course to fetch resource with course disabled. All right. This course error prevents you from obtaining the response. However, there are several elements that are not subject to the same origin policy, such as image tag. After all, images can be loaded from various sources, and we cannot access their content with JavaScript, so there is no issue. The script tag element is also unrestricted. For example, when loading Google Analytics or Google Tag Manager, we directly write this type of script tag, and it's never been restricted, right? Therefore, a method for exchanging data like this emerge. Suppose there is an API that provides user data and they offer path like this. Instead of returning JSON, it returns piece of JavaScript code. Alright, that's interesting. Okay, as the result, my web page can receive the data using setUsers function. Okay, users from API. However, hard coding the function name like this is inconvenient, so the common format is this API users callback any function name. So response becomes like this. If server does not properly validate and allows any characters to be bypassed, we can use URL like this. Okay, so any function name will become this. So in this case, the response becomes like this, and probably, as you can see, those two functions, those two JavaScript functions will be executed. So we have successfully inserted the desired code into the response, and the technique can be used to bypass CSP. For example, let's say we allow the script from certain domain, and domain actually has URL that supports JSON-P. They can use it to bypass CSP and execute the code. For instance, okay, the content security policy allowing this source from the Google basically, but it is loading from example.com with user content. Okay, this is on submit. Okay, so since we use Google reCAPTCHA, we include the relevant script and add google.com to the CSP. Otherwise, http google.com reCAPTCHA API JS will be blocked. Like this one will be blocked if we don't add like right here. But coincidentally, this domain has URL that supports JSON-P. Oh, okay. So if malicious user somehow adds this, if there is security content security policy like this, it could be bypassed. This way, an attacker can use it to bypass CSP and successfully execute the code. To avoid this situation during the configuration, there are few approaches. First, make the paths more stringent. Not sure what it means, but I guess what he says, like, have more determined rules or something. For example, set it to Google reCAPTCHA. Yeah, so basically it says like just add extra path to just be more protective instead of like using the root URL. To reduce some risk. Why say reduce risk instead of completely preventing risk? You will find out later. Second, check which domains have JSON-P APIs available. There is a repository called JSON-B that collects JSON-P URLs from well-known websites. Okay, I haven't knew about this one. Although some have been removed, it can still be a reference. The previously mentioned CSP evaluator also kindly reminds you. Oh, that's extremely old. Okay, 6 years ago. Not sure. Okay, the previously mentioned CSP evaluator also kindly reminds you. Yeah, so I always recommend when like researching CSP bypasses, just use the CSP evaluator and you will get like what you need to do basically. And if you still are not understanding fully what you can do to bypass the CSP, ask ChatGPT. So use those two tools together and it will be enough for the most cases. But of course, not every time that could be bypassed, so keep that in mind as well. Okay, although the JSON-P presented as powerful earlier, allowing the execution of arbitrary code, some websites restrict the callback parameter of JSON-P. For example, the certain characters like from A to Z are allowed, so we can now only call function at most, and we cannot control the parameters. Okay, all right. What can we do in this case? There is another term called same origin method execution, abbreviated as SOM. The idea is that although we can only call functions, we can execute methods under same origin website. Okay. Okay. Let's continue to other methods. What happens when CSP encounters server-side redirection? If the redirection leads to different origin, when it's not allowed, it will still fail. However, according to the description CSP spec, paths and redirects, if the redirection leads to different path, it can bypass the original restrictions. Okay. Okay, so it is actually using the local host on Google right now. If CSP set to like this specific path, since the path is considered both test and a test, scripts will be blocked by CSP. However, the final, like this one, will be redirected to the server side, to Google Complete Search, Client, Chrome, JSON-P, this. Since it is redirection, the path is not considered and the script can be loaded, thus bypassing the path restriction. With this redirection, even if path specified completely, it will still can be bypassed. Okay. Therefore, the best solution is to ensure that website does not have any open redirect vulnerabilities, that there are no domains that can be exploited in the CSP rules. All right. So, and this is another bypass. In addition to aforementioned redirection to bypass the path restrictions, there is another technique called relative path override, RPO, that can be used on some servers. For example, if CSP allows the path like this, it can be bypassed as follows. So like this. Oh, it's using some kind of path traversal while also doing little bit of URL encoding, as I guess. So it's going to Angular.js, and basically it's like bypassing it. The browser will ultimately load this one. This works because for the browser, if you're loading file named this located under here, which is compliant with CSP. However, for certain servers, when receiving the request, they will decode it, effectively requesting this, which is equivalent to okay, I guess this method is working for certain kind of servers, certain kind of backend languages. By exploiting this inconsistency in URL interpretation between the browser and the server, the path rules can be bypassed. The solution is not to treat this as this slash on the server side, ensuring consistent interpretation between the browser and the server to avoid this issue. Okay, other techniques. Yeah, I guess that will be way more than needed for CSP bypasses. You can read this one as well for you, basically, but for me what's usually more interesting is like second article to check, because CSP bypasses I rarely had chance to doing some bypasses, because not all of the targets will use CSP. So still, like, let's go one step further as well. Okay, bypassing your defense, mutation XSS. Right here, it's like the most interesting for me at least. Okay, when we talked about sanitization earlier, I reminded everyone not to attempt implementing it themselves, but to use existing libraries instead. This is because the waters are deep and there are many pitfalls. But do these libraries also have issues? It is possible, in fact it had happened before. One common attack against sanitizers is called mutation-based XSS, also known as mutation XSS or MXSS. Okay. Before understanding MXSS, let's take a look how sanitizers typically work. Alright, cool. Based on our previous experience, the input sanitizer is the string that contains HTML, and the output is also a string containing HTML. Here is an example how it will be used. So this is the user input, and it uses like sanitizer and sanitize function for your input HTML, and then it will save to the document. Hi. So how does the sanitizer work internally? I never gone too deep into this, but let's keep checking. In fact, the internal operation is similar to sanitizer we implemented using Beautiful Soup. The parse input HTML into the DOM tree. Delete invalid nodes and attributes based on the configuration file. So yeah, I guess it's just uses library and library configuration and see like which event handlers and which type of tags they want to remove from the DOM probably. Serialize the DOM tree into the string and return the string. This process seems to have no issues, but the devil in the details. What if HTML that appears to be safe is actually not safe? Wait, didn't we already sanitize it? How can it be unsafe? Let's look at the example first. Okay. Browsers consider it, in quotes, feature. Okay, before continuing this, let me quickly give me Alright, let's go. So the browser is considered software that, in order to handle various situations and comply with specifications, it may not display the HTML exactly as you see it. For example, consider the following example. So this is just like a content, this is the script, content inner HTML, and then some HTML as well right here. Putting a h1 inside table seems fine, but if you open the web page, you will notice, okay, it's not inside. Okay, I haven't knew about this one. The structure of HTML has changed. It becomes this instead of this. Okay, the h1 that has been inside table has jumped out from it. This happens because the browser, based on the HTML specification, determines that h1 should not be inside the table. Okay, so it kindly takes it out. From the history of web development, it is normal for browsers to try to fix invalid HTML. After all, it's better than throwing an error and displaying the blank page. Alright. This behavior of HTML strings being changed by the browser during rendering is called mutation. And the XSS achieved by exploiting this behavior is naturally called mutation XSS. Alright, it's way more clear, for me at least, what is mutation. So this, I guess, is the mutant of of this. It's a mutant. Okay, let's look at another example. So as we can see, it's pretty similar, but right here is SVG, and inside SVG there is a paragraph tag, but it's not closed. So rendered result will be, okay, the SVG will go to the top, but P tag will go to the bottom and also closes itself. Okay, the browser thinks that P should not be inside SVG, so it moves P out of the SVG and also fixes the HTML by adding closing tag for P. What about this even stranger example? This time instead of P, it's closing P. Okay, so the SVG, and inside the SVG there is closing P tag. And right now the result becomes like this. It will be like P tag will be inserted inside the SVG. So yeah, it's kind of interesting. The browser automatically fixes the closing P by adding P in front of it, but tag is still inside the SVG. Note, the behavior of Chrome browser has been fixed now, so, and it will be adding like this. So currently we cannot reproduce this situation, but let's continue. Okay. Okay, now something interesting happens. If we take SVG paragraph tag hello SVG and pass to inner HTML, what will be the result? So yeah, this is another code example. Basically the result will be the P going to the bottom. Okay, not only the P tag, but even following okay, let me check. Not only the P tag, but even the following hello jumps out. Oh yeah, hello as well. Everything that was originally inside SVG is now outside of it. So how it does this series changes help us to bypass the sanitizer. This requires combining it with the sanitizer process mentioned earlier. Let's assume our inner input HTML is like this. The first step of sanitizer is parsed to the DOM tree. Based on previous experiment, it becomes like this. It looks completely fine with nothing to filter. The next step is to serialize the DOM tree into the string, resulting in this one. Next, our front-end team received safe HTML and executed this one. So the resulting HTML is as follows. This. For the sanitizer, P and hello inside SVG, but for final result is different. They are placed outside. Therefore, though this mutation, we can make any element jump out of SVG. You might ask, so what? What is the use of this? There is where it gets interesting. Alright, finally. The magic of HTML. The style is magical tag because everything inside this tag is interpreted as text. For example, okay, if you this will be interpreted as text. This is pretty interesting. Okay. Oh, I probably know what he's gonna do. He's gonna throw this out of the style tag somehow. Okay, it will be interpreted as this. Imagine this is just a text. The black text represents the text node, but there is an interesting part. If we add outer SVG, the way the browser interprets it, it will be different and everything changes. The current HTML source code is so like this. The interpretation, oh, it's added SVG. So okay, the interpretation result is like this. the A inside the style becomes the actual HTML element, not just plain text. This is where you can do some tricks with some mutation XSS. Okay. Let me quickly. Let me quickly block this guy. Okay. So yeah, the A inside the style becomes actual HTML element, not just a plain text like right here, and it will be displayed as this. So here we simply added the A with content of style this. Okay, so we can, instead of A, we can add the payload. Although it contains the style closing tag, it does not close the previous style. Instead, it becomes the part of ID attribute. Same goes for image tag. It is not a new tag, but part of attribute content. However, if we remove SVG, we can change it like this. It to this. Okay, since A is no longer an element but just a plain text, it doesn't have any attributes. Therefore, the style closing tag will close the previous style, resulting in this. Alright, this is pretty interesting how you can use the style tags and mutation XSS for certain bypasses. This is really interesting because you can use this knowledge to actually construct pretty powerful polyglots for XSS and then like throw it everywhere. So yeah, this one looks kind of awesome. The image inside the ID of A was originally just a part of attribute content, but now it appears as an actual HTML element because of preceding style closing tag. From the experiments above, we can conclude that wherever is there outer SVG for style, it is important because it affects how the browser interprets it. Okay, so putting all together, we mentioned the browser's mutation at the beginning, which allow us to make all elements jump out of SVG. We also mentioned that whether there is outer SVG for style is important. Combining these two concepts, we can have mXSS. On September 19, 2019, DOM Purify released version this to fix mXSS vulnerability that bypassed checks using mutations. The problematic payload at the time was this: SVG, paragraph closing tag, and then style, and like A with ID, closing style, and the payload, and the like closing of this ID, I guess. After parsing this into the DOM tree, the structure becomes like this, and as we can see, the payload right here will be executed. The browser does a few things here: converts P to like P normal tag and closing tag, automatically closes SVG, style, and AL tags when DOM Purify checks based on this DOM tree. Since SVG, P, style, and A are all allowed tags, and the ID is allowed attribute, everything is fine. Therefore, it returns serialized result. Yeah, exactly. When user program parses this string to inner HTML and aforementioned mutations occur, all the tags jump out of the SVG, resulting like all the tags right here, resulting in this. Because style also jumps out, the A element no longer exists and becomes a plain text. Okay, as the result, the style prematurely closes, causing the hidden image to become an actual HTML element within the attribute content. This ultimately leads to XSS, right? So fixing the issue, I guess this is not really interesting for us, but I guess that issue was fixed. Conclusion: when I first encountered mutated XSS, I felt confused and didn't fully understand it. In order to write this article, I went through the context again and tried it myself and felt like understood what is going on. Understanding its concept is not difficult, but understanding all the details requires a bit more time. Moreover, the issues were discovered already been fixed and it's not possible to reproduce with current browser. Oh, come on. Which is kind of trouble. But we should take a look after like if some new vulns occur. We could try exploit those. So mutation XSS is pretty advanced topic within like XSS fields, but we also cover this because it's kind of interesting how you can abuse the browser functionality by itself to like construct certain payloads. That's pretty interesting. Okay, but what if, for example, some kind of legacy old servers are using older versions, or maybe the people like working somewhere at certain company also using older browsers, which are actually the case for some companies. And for example, if you submit payload somewhere and that will be the case, it could lead for blind XSS. So when you are constructing blind XSS payloads, I guess like putting all together the payload like this, like closing style tag with SVGs and stuff like that, could be pretty powerful. Yeah, this is pretty interesting bypass, I gotta say. Okay, and right now the last article about XSS, and then after this I guess we gonna continue on other vulnerability types finally. So this is like universal XSS, so I'm kind of curious what it is actually. All XSS vulnerabilities we mentioned earlier are mostly caused by negligence on the part of website itself, allowing attackers to execute JavaScript code on the website. However, there is another type of XSS, but even more powerful, as in the title suggests, universal XSS. The reason is simple. This type of XSS attacks targets not the website itself, but the browser built-in plugins. Okay. Since it is vulnerability in the browser, the website itself does not need to have any issues. Okay. Even with a purely static website, it can be vulnerable to XSS. By attacking the browser, the impact achieved is the ability to execute code on any website. Therefore, this type of attack is called universal XSS, or UXSS for short. So how the UXSS vulnerability is created? Let's look at a few examples. Okay, I wonder if this could be if this could actually be applicable for bug bounties. Like, I'm not sure. Maybe if some kind of program, bug bounty program, uses browser plugin, then it might be interesting to check. But let's see. Okay, in the paper titled Subverting Ajax, the UXSS targeting Firefox is described. The Adobe Acrobat plugin on Firefox had vulnerability where it not properly check parameters. By loading PDF and appending parameter like fdf equals JavaScript alert to the URL, the XSS could be executed within the PDF. Okay, so for example, the https example.com, if you open PDF file but append this to the end, it will load the alert. Simply loading this URL would execute the JavaScript code on the origin, which is known as XSS. Okay. Although the original paper did not provide detailed information, I assume underlying principle in that plugin uses the value passed by FDF parameter to execute functions like window open, allowing the execution of code with using the JavaScript pseudo protocol. Okay, but this is this is like a dinosaur technology exploit. But yeah, it's kind of interesting. Like on PDF files you can execute, you can abuse certain browsers plugin by this. Okay. In 2012, Takeshi reported a vulnerability issue UXS via Android browser application and intent extra. Okay, in the world of Android, there is something called the intent. Yeah, the intent is basically the object which is used to communicate between like multiple applications. Like this is how I usually explain the intent, which represents an intention. For example, if you want to open a new screen, you will send intent saying, I want to open a new screen. So basically you are communicating to your screen, like if you want to open, use another application to like open certain thing. This could be used like mostly it is like Java objects, which are like sending data from one to another. Basically, if you want to open Chrome and browse a specific page, you can write the corresponding code based on this intention. Okay, Android intent action view. This for Chrome app. Set the URL and send the intent. So it's basically opening this application, and on that application it's sending data, setting data, like it will just open this website basically. In 2012, someone discovered that by first opening this, then opening JavaScript alert code could be executed on the https example.com URL, resulting XSS vulnerability. The full complete code looks like this. Oh, right. This is too much to read actually. Okay, this is finally not that old vulnerability. Okay, in 2019, Michael Benkovsky reported the vulnerability. The issue like this number: security SIM origin policy bypass and local file disclosure via portal element. Okay, this XSS was executed through the latest feature portal tag. The cause of this vulnerability is similar to Android case mentioned earlier. There is a simple code snippet from original report. So it will just create the element, it will use the source of the website, and then it will like use other source, and it will use some kind of post message method. So I can see for same origin policy bypass, when you load URL inside the portal and then load the JavaScript pseudo protocol, it will execute the JavaScript on the origin of previously loaded URL. In other words, you can execute the JavaScript on any URL, making it XSS. The vulnerability was rewarded 10k bounty. Okay, that's crazy. Yeah, because this is like serious vulnerability. It could affect Chromium browser, so it's pretty powerful. That's why it's like getting 10k bounty for sure. Okay, Chromium XSS triggered by downloading images. This is even newer compared to those. Then you right click on the image on Chromium, choose to download it. Chromium dynamically executes the piece of JavaScript code in the background. It calls internal JavaScript functions like this. GCR web image fetch get image data. Okay, and what is this actually? Here the %s is the file name of the image. Ooh, okay. However, this file name is not properly filtered. So if the file name is like this one, the code will become okay. So it basically will just escape the single quote, execute alert, and then just create new single quote. So of course you can replace it with the any code. Alert one is just an example, as in many stuff. In addition, there is domain A that embeds. Okay, I guess I was just curious for this bypass. So multiple XSS in Brave browser iOS app. The Brave is privacy-focused browser on Chromium, founded by blah blah blah. The iOS app of Brave has been found to have multiple unique XSS vulnerabilities by Japanese security researcher Muniaki Nishimura. He also reported XSS in Chromium mentioned before. Okay, I guess this guy did a lot of work exploiting browsers. So that's pretty cool. The cause of these vulnerabilities is similar to what was mentioned earlier. It's due to app dynamically executing the JavaScript code without properly filtering the input, resulting in the generation of XSS. For example, there might be the piece of code like this. Okay, self-type, web view, evaluate JavaScript. Okay, and we can control the version variable. Yeah, if the user controls certain variable, at the same time the script is executed at top level, allowing subframes to attack the parent and perform XSS on the other origins. For more details, alright, okay. The XSS vulnerabilities like these are usually beyond the control of websites because the vulnerability lies in the browser itself. So yeah, those are browser vulnerabilities. And the main takeaway there, I guess, when you think about XSS, don't only think that they're only XSS on web pages. Of course, they're gonna be XSS in the browser themselves. And especially, it could be really interesting if certain browsers are being used in the backend. So you might want to chain these type of vulnerabilities with, for example, with SSRF. If some old ass browser is being used somewhere to communicate between servers, like render some stuff, you can use exploits like this actually to achieve something great. So yeah, this is also really important to understand. Okay, so for browsers, this is actually significant vulnerability. Just think about it. If attackers successfully exploit XSS, they can read your Gmail, read your Facebook messages, and take away all your data. It is very frightening situation. As users, all we want to do is keep our browsers updated and to the latest version and hope for vendors promptly fix these vulnerabilities. Yeah, another key takeaway is to update our browsers, because the smart guys like these can like find bugs which actually could affect a lot of browsers, like billions of users for sure. So those are really severe vulnerabilities. It's not like critical, they are affecting like a lot of people. So yeah, we have completed some of the bypasses: mutation XSS, universal XSS, and common CSP bypasses. I guess if you think about bug bounties, only this article have some things that you could take away. This one for universal XSS, it will be very rare cases when you actually can like use this knowledge in bug bounty, like regular programs. Mutation XSS as well, it's like very rare cases. You have to extremely go deep into something to use these. So yeah, and the third part will be attacks without JavaScript. So those I was actually waiting for, because those have some really interesting attacks. So who says you have to execute the JavaScript directly to attack? Yeah, so we're gonna explore those tomorrow, I guess. And basically I don't have too much to offer today, because the plan was completed way earlier than expected. So this is pretty interesting. And also another thing I just wanted to announce, so I have on the Discord server, I have one competition, actually the contest running. If you want to get some like if you want to get 4th tier membership, which actually pretty expensive, which it does include a lot of things like hacking videos, like private hacking videos, and a lot of channels on the Discord. And one really important thing is actual collaboration with me. So you will get 2 hours for that month, and like I will show you a lot of interesting things privately, and we will collaborate during those 2 hours. And if we find any bug, so we could split the bounty. So this is like the part of the membership of 4th tier. So you can actually win this 4th tier membership if you participate in the Discord. Just check the announcements, and I have announced that I'm actually hosting the meme contest. I have created the memes channel. If you want, you can add something funny, and we will see, like the best one probably will win. So hopefully we will brighten our days with this thing, not only share the knowledge between each other, but still like we can also have some fun. And yeah, it was really fun exploring these topics. It was really in depth about XSS, but finally we're gonna check attacks without XSS tomorrow. So looking forward to it.